Greetings, Bafwetu. Now I want us to concentrate strictly on analytical geometry of grade 12. This is grade 12 stuff. But I cannot jump in grade 12. Finally, I have to go a little bit back to grade 11 so that we understand what is happening. Analytical geometry, there are some concepts that are very important at grade 11 as well apply at grade 12. If I can make an example, this is the kind of geometry, they call it analytical geometry or coordinate geometry. It uses points to present our problems are, e.g., let me say this is a system of axes. This is x-axis, y-axis. And we've got these points that are found here. There's a point here, maybe point A. We've got point B. We've got point C here. There are 3 points on the system of axes. Then when you join these points, we have got this line AB, we've got this line BC, we've got AC as a line. Whatever problem that can happen here, we concentrate on the points to solve it. Whether it's an angle, whether it's a distance or what. And in grade 11, sinama formula esasuka now grade 10, sana 11, and the same information we use it to grade 12. Like we said in grade 11, we've got a formula that we use to calculate the distance from A to B or B to A is one and the same line. It's a distance formula, esayifunda. We learned a distance formula that we're going to use in grade 12. But this distance formula, it is taken from a theorem of Pythagoras. And the slide has about the distance formula, distance formula is equal to x1 minus x2 square root plus y1 minus y2 squared. This is taken from the distance formula. There is also a formula, this is a midpoint formula. The formula called the midpoint formula. Midpoint formula is a formula that is used to calculate the midpoint or the center of whatever. It can be a center of a line or a center of a line found in a cycle. Midpoint formula is x1 plus x2 over 2 y1 plus y2 all over 2. And this is the formula we use it in grade 11 to calculate problems. And we take the same information, we go with it to grade 12. Before we come to grade 12, we must know the distance formula. We must know the midpoint formula. We must know also the gradient of a line. Gradient of a line. Gradient of a line. y2 minus y1, x2 minus x1, minus x2. This is the formula for gradient of a line. We used to take it from grade 11 and then we take it to grade 12. And we've got the equation of a straight line. Straight line. There are 2 types of the equation of a straight line as I found out grade 11. We call this straight line SCT. Y is equal to mx plus c. And there's another straight line that said y minus y1 is equal to m into x minus x1. All these formulae, you must know when and how to use them. If you don't know when and how to use them, it's easy to make mistakes when you calculate problems. These are very important. And there's also another formula that we see grade level, we call it inclination of a line. Inclination of a line. Inclination of a line, we call it an angle that is found in first and second quadrant, especially when you move on in anti-clockwise direction. Let's say this is the first quadrant, this is second quadrant. That angle must be found here. That angle must be in quadrant 1 or in quadrant 2. That angle that is made by the line can be between 90 and 0, or it can be between 0 and 180. That angle is an inclination. Then, in other words, the angle must be the element of 0 degrees and 180 degrees. In other words, it must be between 0 and 180 degrees. It's not including 0. I'm excluding 0 here. It's not including 180. It's in between. That angle is inclination. So that you must know the meaning of things before you calculate. Therefore, this is very important. But when you go through those things, you must know. And these are the formulas that they use in grade 11s. And also know the behavior of lines. Let me say this is a system of axes. Again, let's come back to system of axes. Let's say there's a line HR. There's point H. There's point R there. There comes a line. Forgive my accuracy. This is not drawn on scale. Let's say this is y-axis. This is x-axis. Let me say this is VW. VW. I join these coordinates. I join these points. Let me say this is parallel to. The word parallel means they are heading to same direction. They are not equal. It doesn't mean that those two lines are equal. It means there is equidistant between them. There is equal distance happening between them. When these lines are parallel, according to analytical geometry and according to geometry, the gradient of this line, m of HR, is equal to gradient of VW. When these lines are parallel, then there is characteristics that is happening between parallel lines. Their gradients are equal. You must also know that that is taken from grade 11 work, but we go with it to grade 12 because we have to apply it when you find problems. Okunye nokuthi kwenzekani uma be line be perpendicular. This is a system of axes. We've got x, we've got y. There is another line coming from this direction. There is another line coming from this direction. Let me say roughly there is angle between them is 90 degrees. Then it means this line, line AB and line CD, these two lines are perpendicular. They meet at 90 degrees. Therefore, when you look at this thing according to analytical geometry, we say the gradient of AD, when it is multiplied by the gradient of, I said AD, I'm sorry about AD, gradient of AB times gradient of CD, it gives the product of -1. This is now the formula or the rule, the law. We know one thing, that when two lines intersect at 90 degrees, the product of their gradient is equal to -1. That is a rule that we're supposed to know. We take that rule, we go with it to grade 12. So that when we start grade 12, we already know what is it that we're supposed to know, and we have to apply it in the next grade. These things are very important. And there are some terms that are very important in grade 11, like collinear. Collinear. It's a very big word, collinear. There's this prefix co. It means together with. Then here, e.g., let me say we've got 1, 2, 3. Point E, point F, point G. When these 3 points are collinear, they exist in one line, the one line being EG, the bigger line. In other words, this line is so straight such that all these points are found in, those 3 points are collinear, they exist in one line. There's one thing we know about collinear point. Their gradients are equal, not gradients of points, gradients of these small lines, EF. Gradient of EF is equal to gradient of FG, is equal to the gradient of this. These small lines are found in this big line, as well as the gradient also of a bigger line, EG. We've got the gradient of EF being equal to the gradient of FG being equal to the gradient of EG, because these points